So the first algorithm we are going to discuss is weighted round robin. So with Traffic Proxy, we have developed an abstraction layer that is called Traffic Service, which has a built-in feature that allows user to easily use weighted round robin algorithm. The major difference between weighted round robin and a round robin is how weights are configured. In the round robin algorithm, you don't have any influence how traffic is distributed among other backend servers. They roughly get the equal amount of traffic. Whereas for weighted round robin, we can configure weights for each of the backend server that is added to the server pool. So now we can ask the question, when should the weights be manually configured for weighted round robin, or when should I rely on round robin algorithm and its decision process? Well, in some specific use cases, you can have some servers that have fewer resources. For example, slower CPU, less memory. So in that case, you need to configure the weights manually and redirect more traffic to the servers that have a much powerful CPU installed. So based on those weights, you can decide how much traffic will reach the particular server. That explanation is true for servers. However, in the Kubernetes world, we use pods, containers, and services. We have much more abstraction to communicate with each other. So let's have a look at that aspect from Traffic Proxy perspective. Another feature that comes with weighted round robin is progressive delivery by using Traffic Service. So by progressively changing weights in the weighted round robin algorithm, we can introduce a new way of deploying application called progressive delivery. So basically speaking, progressive delivery allows you to deploy another version of your app and gradually migrate users from V1 to V2 if the V2 remains stable and there is no regression in the application that you have just deployed. That process allows the development team to release features quickly and reduce the risk of potential failure caused by unstable version of the deployed application. That process also allows the QA team to test the application in a live environment, which has tremendous benefits. Because we can try to build pre-production environments similar to the production ones, but they never will be the same. So having such a feature in place, we can test our application on the live environment. One way weighted round robin can be used for QA is to test a feature based on the feature flag enabled, or adding specific header to the request. We will see that example in the practice session when we can add specific header, and based on it, we can redirect user to the newest version. So we can create a new matching rule by using host header together with a header regex feature. By attaching this header for only some user, in this case our QA team, we can test the application on production without affecting our users. Here, we should mention and understand the major difference between deployment and the release. So what are the differences between those two words? So we can deploy an application on a server at any time. We can deploy many versions of the application on one server, on one cluster at any time, but it is not considered released until you have direct traffic into that specific deployment. So we can have a V1, V2, but the traffic hits the only one particular deployment. And once we switch to V2, we release the application V2. Some common techniques for this include canary release. So that's the most common approach when we shift the network traffic slowly. And the blue-green deployment, when we switch the network traffic immediately to another version of the app. So now we can ask the question, how did name canary deployment emerge in our cloud-native ecosystem? So that's the very interesting story. So in the 20th century, coal miners used canaries in coal mines as an early warning signals for toxic gases, especially for carbon monoxide. So canaries are more sensitive to toxic gas, so they will die before it becomes hazardous to human. So canaries were taken into coal mines in cages. Signs of distress from the bird gave coal miner a sign that it's a dangerous place and they should escape very quickly. So the same similar approach we can use in our application. So we can deploy V2, we can see what is happening, what is the behavior of that application, and if something is happening as we expected, we can very quickly roll back to the V1.